Okay, welcome back sa ato ang klase, and we'll continue with our discussion on still on uh, root finding. So root finding. And in our previous lecture, discussed about bisection method. So this is one method or algorithm that is used to find the root of a function or the solution of the function. Uh, it's just the basic idea is to cut the interval into half over and over. So provided nga when you make an interval, naa diha ang root or ang solution na contain. So you cut your interval into half over and over again until such time nga ma-zero in nimo or ma-locate nimo ang root or ang solution, tapos mo stop na din ka sa imong pag-cut into half if satisfy na ka sa imong say required nga accuracy nga okay, stop na ko, okay na ko, na nakita na nako ang solution or root for that particular function. Okay, wherein the f of x is equated to 0. Okay, so it could be any function. In our previous example, ano lang to siya, we have f of x equals cosine x minus x equals 0. Okay? So this is one method. Actually, daghan pa siyang method, but for this particular course or chapter, we'll just focus on two method na important siya. We have the next topic atong i-discuss would be on the Newton-Raphson method in finding the root of the function. Now, why is this important? Na makahibaw ta ani on finding the root of a function, specifically on the bisection method and the Newton-Raphson. Well, in physics, it has a lot of application. So one application niya is, let's say you have a function. Say, nani iyang function, that is like parabolic siya. So initially na ako sa 0. So this problem actually is projectile. Right? Familiar naman sa projectile motion. Sign na kayo para sa inyo ha. So this is basic. So you have a projectile motion and na kay equations of motion, di ba, ana, i-set up mo. I think upat na siya ka equation. Upat sa x and upat sa y. So you have your x position and also for the velocity, right? So clearly sa kaning function parabolic man na siya. So makita nimo unsa kay value sa x no nga mo pass through siya sa x. So in this case, duha ka book value. This one is yung initial position which is 0. Unsa ka ni siya nga solution. So na siya duha ka root or duha ka solution for this particular function. Now, once you find that one, so you are able to determine let's say this is actually the range, right? Ang range sa flight sa imong projectile motion if labay ka og something tapos at a given initial velocity, okay? Let's say walay drag force, frictionless. So your throw would make a projectile path, right? Projectile motion siya. But if na ako air drag, so different na yung story. Kausap imong equation. So it would be like this, ana siya. Still makakalculate gihapon ka sa iyahang root which is unsa ka ng x diha given nga naanay air drag. So that's just one application on how important it is to know root finding method, okay? Routine. Another is in quantum mechanics, right? So you have your hydrogen atom, okay? So how do we understand hydrogen atom? So actually pinaka-simple mo ng hydrogen atom. So a basic or a solid understanding of the hydrogen atom would actually make way into in order for us to understand much more complicated atoms or molecules ba let's say sa iyang behavior or unsa iyang description sa kana nga example sa hydrogen atom. And solving for the hydrogen atom is provided by using this equation. You have H psi equals E psi. So it's a very simple equation. This is the Schrodinger equation. We'll not go into detail sa pag-solve ani kay advanced naman siya, so it require a lot of mathematical tools nga dapat makaibaw mo. We have linear algebra, complex analysis nga topic aside sa na-complete ninyo tanan ang differential equation and calculus, mathematical physics. Then you discuss mo ani pohon sa quantum, so it would be a lot easier. But for the sake of example lang, so you have this equation, and they found out nga if they manipulate this equation, makaabot sila og form or mathematical statement nga mag-solve sila og root. Okay, mag-solve sila og solution. It's like finding the root. And when they try to find out the root or the solution of the equation, it is given by this energy. Okay? So daghan day siya og root. And ang naka-nice niya is ang iyang roots or iyang solution is daghan siya and integer. You have 1, 2, 3. Dili pwede 1.5, walay 2.5. It's just integer siya. 1, 2, 3, 4, and so on. So this is remarkable based sa ilang pag-calculate. Root finding na siya nga idea. And this energy is energy 1, 2, 3, 4 actually corresponds to the energy level of your hydrogen atom. So you have your nucleus sa imong hydrogen, let's say classical nga model lang. Actually, electron cloud man na siya. So this is energy level 1. Okay? And nado imong electron. Given enough energy sa electron, i-excite mo siya to higher energy state. Then we have energy level 2 and so on. Okay? So just by solving the or finding the root. Okay? Just the root finding. Okay? That's some of the examples lang on kung anong importante kini siya on nindot nga makaibaw ta on how to find the roots of a certain function. Okay? So we'll now proceed with the discussion on the Newton-Raphson. Okay. Ako lang na i-close. So this method on Newton-Raphson is actually built on the idea of Taylor series. So lalaki ni siya dili ni siya si Taylor nga yung naibaw-an nga si Taylor Swift. So this is Taylor. Mr. Taylor, Brooke Taylor. So we shall revisit this mathematical toolkit gamit yung kini siyang Taylor series para sa ato ang Newton-Raphson. So once you know and understand the backbone and idea of Taylor series, then we will be using that in developing our Newton-Raphson. So at least di na mo ma-shock mga anong inana ang equation sa Newton-Raphson. Well, gikan siya sa Taylor series. Okay, and what is Taylor series? Ato ana siyang i-revisit karon. Quick review lang. Okay? So overall or bottom line sa Taylor series is just an approximation. So i-approximate niya ang imuhang function with a series. Okay? So if you have, let's say, if you have a sine function, let's say at x equals 0, murag ingon ana ra siya ba? Let's say this is your sine. Tapos ang Taylor series, siya nang i-approximate ang imuhang sine function by deriving a certain equation nga summation siya. Okay? Say any unsa na siya nga form say x to the something. Okay? So we can approximate any function using Taylor series nga expansion or nga form. And let's say at x equals 0. Okay? So we'll assume a function nga continuous ang ihang derivative. Okay? Nanamo idea unsa ang derivative, right? I hope naka-discuss na mo sa inyong prof. Pero ano lang siya. So let's say define ang imong function and continuous ang iyang nth derivative, meaning i-derive mo siya up to how many times define gyapon imong function at this interval. Okay? And we can integrate that one to obtain this equation 3. Okay? So you have this function, tapos na-exist ang iyang nth derivative. And if you integrate that one at this limit, okay, we know nga ang integral ana is just this. Diba? Ang integral ani is, ang result sa integral ana is, actually ana siya. Ang result sa integral is this, n minus 1, okay, x naught evaluated from a to x1. So, nganong n minus 1 man na, then kani kay n, di ba opposite man na ang relationship sa imong derivative and integral. So, this is derivative, this is integral. Okay? So, inverse man na siya. So, if na ako'y nth derivative sa imuhang integral, sa integrand, if you take the integral of that, makuhaan ang iyang order sa imuhang, kumbaga ma-cancel ang imuhang derivative, or in a way, if in general, if ika-n ka nag-derive, mahimot na lang siyang n minus 1 nga derivative, or n minus 1 times na lang nimo siya gi-derive instead na n times, like this. Ako yung function dy dx, integral na siya. So if ako ana siyang i-integrate, that becomes y. Okay, this is first derivative raman na siya, it becomes y. But if it so happen nga second derivative na siya, then this becomes dy, right? So first derivative, so it's like that. I hope clear. So feel free to ask me lang if you have question. You can comment down below or email me or message me. So you've done your first integration, you integrate it again. It's like integrate na siya o another, integrate na po din mo siya ikaduha. So from a to x2, right? Then this is dx1. So mo na siya, right? The result of that integral is given by this equation 4. Okay? So, ato lang siya gi-derive ba para di ta ma-shock later on nganong kaysa ihatag nako didito ang equation sa Taylor series o sa Newton-Raphson nganong inana man. Basta mo na siya. But at least makakita among idea nga, makakita mo sa Newton-Raphson. Okay, sayo na siya, diha na siya gikan. And I tell you, between bisection and Newton-Raphson, this one, between bisection and Newton-Raphson, the Newton-Raphson is a lot easier. Masayon gyud siya ang method compared sa bisection. You will see how. You will see why later. Ang pag-derive lang niya medyo kuti, pero actually sayon naman siya yung idea. Next is we integrate that one, katulo na pod x3, integrate na pod a to and so on. Integrate mo siya og n times. Okay, continuing that one up to n integrations, we get this equation 5, right? So, di na lang ta mulalis no nga mao gina siya, but actually you can check. Pwede nimo siya i-check kung mao ba gina siya nga form. Pero I tell you mao gina siya, okay? Kana siya nga form. So we'll just have to accept na lang, or if dili ka convinced, and you can calculate it and i-derive if makuha pa gid siya. But for now, we'll just accept it as it is nga mao ni siya. Okay? Given in equation 5. Now, to simplify this one, we need to substitute x for x sub n. So, kaning x sub n, mahimo siyang x. Right? And then, we only want this kani siya nga function. Right? Okay, mao na itong gipangita ang f of x, ang equivalent function niya as a summation or series. So, if we want that one, ato ni siyang ano na siya, f x na, ang instead na x sub n, mo siyang x. Then, this one, kani siya, o kani, ibalhin mo siya sa left side of the equation. Okay? To get a negative, mo na siyang positive, right? F of a plus x minus a f of prime a plus x minus a squared over 2 factorial. Double prime is kaduhanin mo siya giderive. Minus x minus a. This is cube. Okay. 3 factorial. Triple. And so on. Okay. So, imong gibalhin sa pikas, kali sa tanan, plus appeal pag yun right? So, plus that whole thing. Okay? I hope nakapalo na. So, mo na siya equation 6. Where r sub n sub x is, mo na siya. Gi-represent lang siya as r sub n of x. So, this is now your Taylor series nga result. Actually, mo na ni. So, given any function, ma-express siya into this summation. Isn't it amazing? Okay? Ma-approximate mo any function by having a summation f of a plus x minus and so on. You can get the approximate form of your function by employing this Taylor series. Okay, so we'll have an example on this. Let's say we want to approximate the function sine. Okay, so what is the Taylor series expansion of at 0, no? So at x equals 0. At x equals 0. Okay? Recall our formula sa atong Taylor series expansion. We have f of x, have f of a plus x minus a plus x minus a squared over 2 factorial f double prime a plus, so nana siya yung pattern, cube, so this must be over 3 factorial. Tapos, triple derivative a. Kasi tama nang tadiha, ikatulo nga derivative o upat ka terms. So at x equals 0, we'll have this. Your sine function would be like this. F of 0 plus x prime of 0 plus x squared over 2 f double prime of 0 plus x cubed over 3 factorial f to the triple derivative 0 and so on. So para makakuha tag ID, para makuha na to ang form sa imuhang sine function approximation na in terms of Taylor series, then we have to evaluate this kana ug kana. Okay, so what is f of 0? Okay, what is f of 0? So that's actually sine of 0, right? And sine of 0 is just 0. How about f prime of 0? Tara, f prime of 0. So prime is derivative, so you take the derivative of sine, that's cosine, and then evaluate it at 0. So we have 1. Cosine 0 is 1. Next is katong duha ka derivative. Okay, at 0. So, i-derive nimo ang cosine, kaya mo na ang first derivative, di ba? So, ang double derivative is i-derivative na po di mo ang cosine. So, derivative sa cosine is negative sine. Okay? So, negative sine of 0, this is still 0. How about cube? Cube, triple prime or triple derivative. So, this becomes negative cosine of 0. So, this is negative 1. Now, you substitute it back here. Diba? F of 0 is 0. So, wala na siya. We are just left with this. F of prime is 1. So, we have x minus x cubed over 3 factorial. Tapos, if you go on, continue sa... So, na siya pattern. Ang even kay 0. Right? This is 0. This is 0. So, ang 4 niya is 0. Ang mabili na po isang katong to the 5th. So, we have, and so on. So, this is the Taylor series expansion or, yeah, Taylor series expansion of sine. Okay? We have sine x. Actually, approximation na siya. So, I think nakakita na mo ani before. Nagamit na mo ani sa high school ninyo nga approximate mo at small angle, gamit mo ani nga expansion sa sine. It's given by this series or summation. So if you search the internet, yeah, Taylor series, makita ninyo sa ubos nga this is actually the small gini siya ang sine expansion. Tara. Take a look at sine x. You have x minus x cubed plus x to the 5 minus, that's actually what we get. Tara, kani. So that's how powerful Taylor series expansion. Okay? So we'll go back sa ato ang lesson. So how is this related sa ato ang root finding nga topic? It's very related kay diha gikan gid ang Newton-Raphson. Okay. So mo siya kanina. So we can appreciate more the power of Taylor series when we use it in developing Newton-Raphson method, which is much more sophisticated method in finding the roots of a function and mas efficient pa siya. So first, we'll assume that we have a good guess. Okay? Ato i-assume ang imuhang initial nga mga point. Say this one is a very small number. And then keeping just the first two terms of the Taylor series expansion, so looking back sa Taylor series expansion, enough naman nga kani nga term. Kana. Pwede na siya wala. Okay? In developing our Newton-Raphson, just these two terms, f of a plus x minus a, f prime. Okay? So we have this, our Taylor series expansion. So, from this equation, magamit na to ang root finding. Why? How? Ask me how. So, kana, i-set nimo na siya to 0. Then we have your root, di ba? Mama na ang idea sa katong zeros of function. So, if we set this to 0, unsa dapat ang value sa x na ma-0 ni siya? Right? So, we can do that by rearranging. So, we have f of, this is 0, f of a plus x minus a, f prime of a. So, we need to get x. So, ato na siya is rearrange. That's equal negative f of a. Right? Imuhan ning a distribute. So we have x prime of a minus a f prime of a. Diba? And then, imo na siyang, this is equal to, like, libog. So distribute na siya. We have x f prime of a minus a f prime of a equals negative f of a. So that would be x f prime of a equals a f prime of a minus f prime of a. Tama? Mo siyang distribute. Then I divide this one to everything with f prime of a to get x. So I have a minus f prime of a over, oh, this is not f prime. F prime na siya. So this is f over f prime of a. So, kuha na ako ang root. If I know the derivative, the first derivative of that function at point A, and evaluate the function at A. So, ako siya i-evaluate, then I get the solution. Okay? So, I have equation 16. Okay? So, in numerical sense, we can discretize this to be able to solve it using a computer. So, in numerical sense, we can discretize that one as equation 17. So, magsigag iterate, right? So, good kag guess nga x sub I. Substitute nimo na siya diha, then you will get this x sub I plus 1. Next na lang yun is kaning x sub I plus 1. Muna siya mong isubstitute na po din ha. Okay, substitute din he. What you will get here is x sub I plus 2 na, right? Substitute na po nimo diha ang x sub I plus 2. You will get x sub I plus 3. And so on. Until makuha nimo ang value sa x. So when makamo stop na mo na siya ang solution, if the xi plus 1, i-minus nimo siya sa xi, and let's say na siya error nga less than epsilon, then that's good. Ang accurate na imong result, and you stop, you quit the loop, you print the result. Okay. So for example, sa itong previous nga kaning nga equation gamit na to bisection, right? So we'll be using that. We will be using Newton-Raphson method to solve this. Okay. So mamani ang formula. So we need to evaluate f of x, meaning kani siya. Tapos ang derivative niya, right? The derivative of this is just given by this negative sine x minus 1, right? Pag-derive nimo ana, this is negative sine x, this is negative 1, okay, or negative sine x minus 1. So starting at okay, ato we have we know nga ang cosine x equals 1 if x equals 0, wala. If x equals 0, then cosine x equals 1. And if we have cosine x equals 0, so if x equals pi over 2, right? So between 0 and pi over 2, ang extreme niya nga values ba? So it will be reasonable for us na ang iyahang initial value nga itong gamiton is in between. So we have pi over 4. So that would be our initial value to solve for the solution or the root. So somewhere around pi over 4. Okay, so that's why we can use the pi over 4 as our initial. So if you do that, this is the Newton-Raphson. This is x naught, right? Or x sub I, then this is x sub I plus 1. This is the evaluation sa imong function. Tara. Right? I-substitute nimo ang value sa angle sa x, which is pi over 4. And then sa ubos is, of course, the derivative, which is given by this. And then you input that one using your calculator. It is found to be that the x1 is given by this. So notice ang accuracy sa isa pa lang na ka-iteration, di ba doon lang siya sa actual nga result nga to nakuha before. Katong nag-calculate sa root ana using bisection method or even katong graphical. To improve the accuracy, if kasi wala pa na siya nakapasar sa atong limit nga epsilon, right? Kasi inyong program ana kay inyo haman ng e-minus, say evaluate nimo x1 minus x naught. Is it less than epsilon? If not, padayon na sad. Ang kani siya nga value na po, that would be, di ba this is x1? Mo na po na imong i-substitute sa sunod. That's why you have this. This is x1. Right? This is x1. This is x1. The result would be x2. Tara. x2. So this would be now your new result nga pwede mo gamiton as input sa sunod. So makuha na po kag x3, x4, and so on and so forth. Okay. So this is the algorithm in Newton-Raphson. So beginning with an initial guess x naught, the expression is iterated to generate x1, x2, x3, and so on until the result is deemed sufficiently accurate. Okay. So how do we account for the accuracy? Then we have to set a relative error, let's say, of this value. If maabot na siya anang a value or more less than that, then you stop your iteration and then katong latest nga x nga imong gi-calculate, that would be the solution or the root of the function. Okay? So after iteration, i-evaluate nimo ang x sub I plus 1 compared nimo sa x sub I. So if, on the other hand, if the accuracy has not been obtained, we should iterate again. Okay? The while loop, ang pinaka-ideal na ito, pinaka-nice gamiton o applicable gamiton ani nga algorithm to accomplish the goal. So let's open up MATLAB. Actually, nakabuhat na kong code ana and we'll try to look into and kamo po, imo na lang i-analyze given na ang code, nganong inani ang code based sa kaning algorithm. It would be I think masayo na sa inyo sabton na yun kay once nakasabot na mo sa algorithm, then looking at the code, mas dali na siya ninyo magets. And then we will be using that later on in solving other functions, gamit ang lahi nga function, tapos kung ano mga zeros of function, that would be easy for you to solve it using either bisection method or this Newton-Raphson method. So, I think nakita di man ninyo ang advantage sa Newton-Raphson. Masayon siya gamiton. Mas dali siya i-program. Mas dali yung algorithm. Di siya kutiba compared sa bisection. So, I have here the MATLAB code for the Newton-Raphson. So, I name it a function file called root. Tara, root. So, initially, this is the initial value sa imong x naught or x1 or x naught, I mean. So this is 0.8 or pi over 4 close to. And then this 0.8 or initial value will be fed into this function Newton. Tapos kung unsay result ana ihatag niya as x, right? Or could be any value or any variable, but I just chose x para mas anyway mapulihan naman ni ang value sa kani initial kung unsay result ani. So this is a function with a function inside called Newton and mohatag siya og result stored into x, and then this x will be used in this fprintf function to print, okay, kung unsa man ang na-solve niya. So unsay value ana niya yang i-print din. Now, my Newton function is defined inside. Can you see? So, this is one way of making your program. Unlike sa katong bisect ito nga function, going back ani. Ang kada function niya ani is giseparate siya og file. While in MATLAB, you can actually do also wherein mausa nimo ang mga function pa instead na i-divide nimo siya into several files. Na siya pros and cons pero depende lagi hapon na siya kung asa mas gamit given a particular project. Okay? So for this case, ako lang giusa din para mapakita na ko sa inyo nga pwede siya. Okay? You can do this kind of program style wherein ang tanan mga function is nga usa siya sa usa ka file. So this is your function Newton-Raphson. So I define tolerance of 5e to the negative 9. And then my error would be 10 times that of tolerance. Okay. So I have my iterations also, kung pila ka book iterations. And then I have my while loop. While the error is greater than the tolerance, so sige siya o calculate, right? Ang error is mao man ni katong kani siya katong difference bitaw sa imuhang result sa xi o x sub I plus 1. Okay? So I have your delta, which is katong this is it's just a variable. Kato ni siyang this is f of x and tapos derivative of x. Kanini siya nga na equation. Tara. F of x, gitawag lang siya og delta, right? F of x over f prime or derivative. That's why mo ni siya ang tawag. Okay? So your Newton-Raphson equation is just this. X equals x plus katong delta or katong f of x over derivative of x, right? And then I have my iterations para i-count kung pila ka iterations needed para makuha ni mo ang solution or katong root. And then I evaluate for each iteration ang error, which is the delta over x absolute. Okay? Katong imuhang fraction kung kani siya is gamay na kay siya in such a way nga mo less than or equal na sa tolerance, then bukwit na ang loop ni mga while loop and then go on to print, right, the iterations and i-print po niya ang root dito siya. And your f of x function is kani siya y cosine of x minus x. And your derivative is just negative sine x minus 1. Mamuni ka kanina, di ba? So, I will upload this file sa Google Classroom and then it's for you to find out kung i-run ninyo siya at your own PC or even sa cellphone, pwede. And try to find out kung say yung result the same ra ba, pareha ra ba, and how many iterations needed para makuha ang desired result with this given error or tolerance. Okay? Okay, let's proceed. So, kamo na lang i-run ato ha, para at least kamo mismo makakita right before your very eyes ba on sa result niya. Okay, next is, actually MATLAB has its own root finding routines for nonlinear functions. And ang iyang function is, actually ang method nga gigamit niya is kind of similar po sa kung sa gigamit niya. Let's say Newton-Raphson or bisection method. It could be other method. Basta kaya idea is makuha niya ang roots or ang solution sa imong equation. Okay? So for MATLAB, sayo na siya kay built-in naman siya. So it's actually called F0. Okay? So let's try to sa terminal. So type lang mo F0 parenthesis. Then you type your function enclosed with a single quote, cosine x minus x, and then my initial point would be pi over 4. So the result would be C. Isa na siya ka line. Okay? So, if nidiretso ta gamit ani, well, mahatag siya answer, but question na ba, yun sa na pagkuha. Nganong nakuha niya ang yung solution? Well, the idea is katong root finding method. Right? You have the root finding method. Based sa root finding method, the bisection, the Newton. Actually, napay uban ng mga method, wala lang ako i-discuss. But these two methods are enough. Okay? Nganong nakuha ni niya sa MATLAB. Kani siyang F0. Okay? Zeros of function. Kuha na niya. So, we can just use this one, okay, for checking lang ba, okay, sakto rin ato ang algorithm na gigamit. So, kuha na siya. So, one line of code lang na siya. So, later on, if for kuha na gid siya, let's say, practical purposes, na, let's say, outside na sa graduate na mo, na mo sa field, magbuhat na mo og thesis or something, nya mag-need mo og namoy problem sa inyong thesis baron or sa inyong project nga mag-solve og as a solution sa root, pagtaon ni mang root or uh, mag-involve siya og root finding, so you can just immediately use this F0. Kaya anyway, kay mo naman mo gyud sa pag-solve na siya using root finding method. Okay? So you can also try that one in your own PC or sa cellphone and try other functions nga makasolve siya in ani F0 nga function. Makakuha na siya og value sa iyang roots, okay, o solutions. So, not only for this type of function, napoy mga polynomial nga mga functions that wherein MATLAB can also solve. So, if you have a polynomial function, one can actually extract the roots of that equation or zeros of function by just using this command. Okay? So, let's say let's say next page. So say we want to find the roots of the polynomial. Say this polynomial x to the 4 minus 53x cubed plus 1026 x squared minus 8568x plus 2520. So seems pretty long and complicated sa polynomial, but it's very easier for us to just calculate and extract actually the roots of this function. So we can actually make a guess and predict na ang iyang roots ana kay upat ka buok because the highest order niya is actually 4. Okay? So in MATLAB, we can do that by invoking the built-in command roots. Okay? Imo siyang enclose. Tapos kato mga coefficient, i-enclose nimo og bracket. Okay? When you say enclose nimo siya og bracket, it becomes now a vector or a row vector or an array. So ang mga vector component nimo is kato iyahang coefficient. For example, ang say coefficient sa x to the 4, 1. Coefficient sa x cubed, we have negative 53. Sa x squared, we have 1076. Sa x is negative 8568. Tapos diri is actually x to the 0 na siya or just 1. We have 25920. Okay? So, kana. Here we have roots. Right? Imo siyang i-enter do sa MATLAB, then you can automatically generate or extract the roots of that polynomial. Okay, so we have 1, negative 53, 1026, negative 8568, then positive 25920. So if I hit enter, I get the roots automatically. So it's easy. Sayo na kayo. Wala kag while nag-prepare kasi mo hang bread and butter, tapos nag-input ra ka ana, tapos just fraction blink of an eye, solve na niya. Okay? So we have this one. So ang idea sa pag-solve ana niya is nalagihapon sa kaning idea on root finding. Okay? Ato lang gibuhat is ato ang gilay down daan ang foundation as to nganong ang MATLAB able man siya makasolve sa root. That's because of some root finding technique and algorithm nga developed before. Okay? So using the F0 function, one, you can find the roots of a nonlinear equation. And for a polynomial, a more fitting function is you have the roots. Okay, imo namang input diha ang mga coefficient sa imuhang order sa x as row vector, and then voila, solve na dayon. Okay, that ends or culminates our discussion on this chapter, and that is on root finding technique. Okay, so recap, we've basically discussed uh, the essence and application of root finding methods, and wherein nag-discuss ta og duha ka type of root finding lang sa. We have the bisection method and the Newton-Raphson method, wherein the latter is built on the idea of Taylor series, kanang Newton-Raphson. And then after that, we discovered na naade ay built-in root finding pod sa MATLAB, and it's very easy because you just have to use it, and then ang iyahang implementation aning roots and F0 is actually hidden from us user. But since we are physicists, we know giunsa na siya, right? Because we discussed this. Okay. So that would be all for this chapter, and um, I'll be uploading the problem set for this particular chapter, and stay safe mo always. God bless, and reminder lang, always work out sa inyong problem sets from time to time. Advice lang is ayaw paabutan nga sa deadline. Usually, ang deadline man nato is sa end sa semester, right? So, nahinaya lang ninyo buhat kasi trabaho mo 1 hour a day lang, or maybe once a week, at least okay na at least na mo progress ba kaysa dito na mo magbuhat sa day of submission again. Okay? So, stay safe and cheers.